Most commonly we are hearing the terms in these days called relational database, graph database, SQL, NoSQL, big data. So what exactly these terms are? What are these buzzwords? Big data, what is the buzzword graph database, what is the buzzword relational database? So let's have a quick discussion about that. Now whenever we say relational database, RDBMS, Relational Database Management System. So basically it is something which follows relational model of mathematics. Before relational model or relational database, we used to have called network data model, hierarchical data model, and then it came as relational data model. Now these are the data models or the kind of databases which talks about how data are organized. So, NDBMS was network, HDBMS was hierarchical, and relational is RDBMS. With time, everything from file management came to database management. So everything used to be on file management systems. We came on database management systems, and in database management precisely we followed relational database management systems. And you might have heard most of the tools that we use in relational database management systems provided by organizations like Oracle, DB2, and we use structured query languages, SQL, MySQL. These are basically different tools, PLSQL, which are basically we are using everywhere. Now everything was working fine, everything was good, but why this a new term, the buzzword came into the picture, which we call as like graph databases, or from SQL, why we are talking about a new term called NoSQL. Let's try to understand what was the depth between this thought process or this invention or re-engineering. Now whenever we talked about relational databases, RDBMS, we said all the records are stored in the form of rows and columns, and they are stored in a way that they have a relation between them. Now this relation is a mathematical relation. This is the same relational theory that we study in mathematics: union, intersection, Cartesian product, kind of all those operations which are being performed among those relations or the data which are stored in the form of row and columns in a table, which is also called as relation. Basically there is a term which we call as schema, that is the logical description of a database, and for RDBMS we called relational schema. All the data are stored in the form of row and column, maintaining some kind of relations among them. So in a very simple way, if we try to understand, we say that we have a number of rows, we have number of columns, let's say name, age, gender, address, class. Is a very simple structure. Let's say for student database, so these are the attributes which we are storing, and these are the count, like name, A is 1%, B is 2nd, C is 3rd, D 4th, E is 5th, likewise 10, 12, 13. I'm just making some random entries. Address, like this. So if you see here, either a student, whatever information we are capturing are predefined. For example, name is something we have defined, age is something we have defined, gender, address, class we have already redefined for the students, and all the students are being entered into this format in the whole system. Think of a situation that a new information has to be added for all the students. Let it be it's a SSN number, social security number, or let it be some unique ID, for each students, or let be some health insurance number like this, health insurance. Now if we have to add all those parameters, right, so what is the complications involved? We have to re-edit the whole database, we have to add this field SSN number, we have to add the health insurance number, we have to add respective values for all the students which are into the system. Maybe consider any other example. There also, whenever we make these changes in the parameters, we have to make all the new inputs for all the users which are registering in the system. So the best option is to identify and lock these parameters right at the beginning, right at the design time, but it may not be possible every time. It has a probability that with the later future time, with the new information coming up, we may be requiring more details and more details with time, and that requires more and more updates. Think about the situation. How about this, that let's say we have infinite parameters. For example, instead of name and age and other things, let's say we define some infinite parameters right at the beginning, and I use only those parameters which are valid for me as a user, or I use only those parameters which are valid for a user B or which are valid for a user C likewise. My problem will be very much solved. Now the problem is this definition of infinite parameters. How to define what are those infinite parameters, and then how to identify a framework. Now this was the main problem in the relational database, because everything has to be logged, the framework has to be identified, the rows and columns have to be identified, but with time it has been observed that this model may not hold perfectly when the data is increasing, when the number of parameters are increasing and the parameters are not logged. Now how? Consider an example of Facebook. In Facebook, we store most common information that everybody has: name, age, gender, date of birth, and then address, and what you are doing, and your past jobs, and images and videos and friends, and like this. But if you see to your friend's account or your own account, or many of your friends might have shown their political interest, they have shown the TV serials they watch, they have shown the kind of games they play, and you might have got several gaming requests from them. They have shown the kind of groups that they have made, they have shown the number of groups that they are following. They might be displaying their kind of interest in the movies as well. So likewise, there are n number of parameters already defined for everybody. It depends upon the users. For example, I may not think of choosing any political interest or any movie interest or any TV serial interest or playing any game on the Facebook. Similarly, some other user may think of using all those parameters but not showing their photographs. So like this, we have observed that if we try to use a relational database model directly, it may be a problem. So what to do that? Why not to tweak this relational model, and then something which came started into existence and people started working on, that is called graph data model. So from RDBMS, now we are migrating towards graph databases, which are more or less similar to relational databases. Only the architectural differences exist, like how we are storing, what are the key value parameters, instead of row and columns, what are the parameters that we use inside. And likewise, we go and design so many applications on the basis of graph databases, and then again it is used in the big data, it is used in the ontologies, it is used in the systems where we are not sure how soon we are going to change the database, but we use these models which are scalable enough, portable enough, and then again we use in all those big data applications. So this was just an introduction how from relational database to graph database this migration came up, and how these tweaking is very helpful. This re-engineering is helpful in redesigning the cutting edge technologies. So we'll come up with more details into the next lectures. Thank you.